So how many of you possibly think that you can deliver zero defect quality code without using unit testing or any other testing frameworks? So in this tutorial, I'm going to convince you that you need a powerful unit testing framework to deliver quality code. So you want your software product or service to be of top quality. You are concerned about the quality of product or service that is being delivered to client. Like you see in this picture, what you have is a 1-star rating for your product, which is not a desirable rating that you want to be, you need to be upon a product. You would like to employ the best software testing tools to turn around this situation. So let me present you the 3 tools that will help you achieve this objective. So you can use JUnit as a unit testing framework for the code you write. You need a reliable and repeatable way to test your program. First, let's talk about what is a unit test, right? So a unit test is a test that examines a single unit of work in isolation from other units. All unit testing frameworks should follow the below points. So each unit test should run independently of all other unit tests. The framework should detect and report errors test by test. It should be easy to define which unit tests will run. Now, it is a difficult task to put together a framework that can address all of the above. But luckily, JUnit has saved us the trouble. So with a unit test, it's not enough that a test is passed when you first write it. It is important that the test still passes when it is integrated with the rest of the application. So here, I'm going to create a very simple, show you a very simple class that you are going to write a unit testing. Now this is a simple example where you will compute the price of a product and the tax and return back the product price as the sum of the price and the tax. So let's create a new package. Let's have it pricing.service. Create a new Java class. I'm using IntelliJ. If you're using Eclipse, please do so. Let's say I write a method which returns, which calculates the product price. It is being given a price value and then a tax value. And you have a final double product price. Which will be the value of price and tax, and you return the product. It's a very simple calculation. So it should be double. This should also be double. Okay. So we are going to write a test case for this. So I just want to include test as a test like this. And let me create a package that is in sync or is same as the package of the source code. So let me create a new Java class and product test product price calculator. Now let's say I write a simple public static void main. And let me use my product price calculator. And let me try to compute the value. So let's say I have final result. Final product, let's call it product price. Is equal to, let's give it some numbers. Now, if this product price is not equal to 60, we're computing it ourselves. Remember, we're not using a testing framework. We are writing it on our, we are trying to test using another Java class on its own. So that's what we're trying to do here. So if product price is not equal to none, then we're going to run this. So what happens here is you see that the test is complete. It doesn't give any errors or doesn't return, doesn't display the system.out.println here, right? So everything is good, but you have to look at the logs in order to show this. Like, let me change this. So let's say if I change it to 30, okay, and run it. So as it is building and it will run. So you get a bad result of 40, right? So which means that you have to observe the log in order for you to determine what has happened to your code that you're running, right? So this is where, so you can maybe improve this by um, throwing an exception. So every time my price result is not correct, then let me throw an exception. And you also have other scenarios. So how will you calculate the product price when there is a coupon that is being applied to it? So how do you do it when there is a couple of products that are bundled and one product is free? So in those scenarios, you will be having different different methods, and you have to test each of those methods, right? So what we will do is we are going to just take this scenario. Say we put the entire code here. Let's say in our main class, we'll instantiate an instance of the main class called calculator. So we need to get this illegal state. You need to handle this illegal state exception. So for that, I'm going to count the number of times the test methods have failed. Here we only have one method. This will now let's run this. So what we have done here is we have created one method for testing the calculated product price for tax, and then we are trying to catch the error if it's not the expected result. Then we are throwing an error. So now let's try to run this. So you get the bad result 40, and then you see that there is one error. So if you write another test case for, let's say, applying a promotion, so you will be using as many try catches as there are you have to test methods, right? So which is not sometimes if you miss a simple try catch, then you will get the error count as something different than what you want it to be. So your expected behavior of the app as a whole changes. So you don't want that. So these points, right? These ability of a tool is being given to you by JUnit.